Hey guys, this is Plutonium here and welcome to a brand new Minecraft video on the channel Plutonium Plays. This is my first Minecraft video and talking about content that I'll be posting. This is basically a Minecraft channel where I'll be posting videos on redstone tutorials, let's plays, new updates to the game, and basically all those things which are coming on the Java edition of the game. So let's get cracking. So to begin with, first and foremost is a redstone signal. This redstone signal is the primary thing which makes all redstone contraptions work. Obviously, redstone signal has signal strengths all the way from 0 to 15. So if you open our F3 menu, we can see that this redstone which I'm standing on is power to 15, which you can see on the right side beneath the targeted block Minecraft redstone wire, and power 15. If we move one block ahead, the power decreases by 1, 14, then 13, the next block 12, 11, 10, 9, 8, all the way to 1 and then 0. So, redstone signal strength decreases for every one block of redstone wire. My keyboard seems to make a little noise, please don't mind that. The redstone signal can travel a max length of 15 blocks, which we can see from these signs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 blocks. Coming to a different aspect of redstone, which is different from signal strength, is redstone power. We can see that redstone power is of two types, strong power and weak power. Strong power can be transmitted across two blocks as 1, 2, and weak power could only be transmitted by one block. So this one, just this one. So when the lever is activating this redstone is strongly powered, which means it can transmit redstone signals through two blocks. What we see is when this redstone is activated, it is strongly powered, but the block next to it is actually weakly powered, but it's activated. And when something is activated, the redstone component is actually performing its functions, like this redstone lamp is turned on. When this redstone torch is weakly powered, it can still power this next redstone torch, but this one is not powered. Still it's activated. But since it's not powered, if we place any more redstone lamps ahead of this, the lamps are just not going to get powered. Speaking about weak power, this redstone block here is weakly powered, so it is actually transmitting its redstone signal only through this block, which means this redstone lamp. We can see that this redstone block is weakly powered and activated. The next redstone lamp is not powered, but it's activated because it's being powered by this redstone block. But the next redstone lamp is not going to be activated because the block behind it is not powered. Speaking of redstone components which transmit strong power and weak power, talking about a redstone repeater. A redstone repeater always gets strongly powered by anything that's behind it, so it's always going to transmit its power through two blocks. So this redstone repeater is going to power this block, which in turn is going to power this redstone lamp. Now since this block is powered, it can transmit the power into any one of the remaining 5 directions. Not this way because there's a repeater here which is not going to get powered backwards. Redstone dust can also transmit strong power in the direction of the block that it's facing, which means this redstone dust which is facing towards this block is going to strong power this block. Actually, this redstone is going to be strong powered. It's going to weak power this block, which is going to power or activate this redstone lamp. Redstone torches. We are not talking about these ones, only this redstone torch. As an example, redstone torches strongly power upwards, which means that this redstone torch is strongly powered when we talk about transmitting power upwards. And this block is being powered by this redstone torch, which in turn is going to power the redstone lamp. I say in turns instead of in turn. Pressure plates are blocks which transmit strong power downwards. So when you are standing on a pressure plate, like in this situation, you can actually see that right now. So what I'm going to do is I'm going to actually shoot a bow at this, and we can see that the block beneath is getting powered, which is powering this redstone lamp. So pressure plates transmit strong power downwards. But in other directions like sideways or up, it only transmits weak power, which we can see right here. The redstone lamp above it and beside it is only getting power. The lamp above it is not, and the lamp beside this one is also not getting power. Comparators also do the same thing. Comparators can also strong power the blocks behind. Observers do the same thing. So do levers in the direction of the block that they are attached to, like this, and even trap chests. You can see that redstone lamp is down there and is getting powered. However, there are some exceptions in the way that redstone components are powering blocks, such as when we are talking about this redstone torch, which is being placed on the top of a block. It's always going to power strongly upwards, but it's not going to strongly power sideways. We can see that this lamp is powered, but this next one is actually not. And also that a redstone torch, when it's placed on top of a block, it cannot power downwards because it's actually going to receive the power from the block it's attached to. Similarly, if we are placing a redstone torch on the side of a block, which we can see here, it's always going to strongly power upwards, but it's only going to weak power sideways and downwards. Similar is the case with levers and buttons, but the difference is that the levers are only going to transmit strong power in the direction of the block that they are attached to. We can see this lever is being placed on the top of this block, which means that the block it is attached to is below the lever, which means this lever is only going to strong power below, not in any other direction, which we can see right here, is that beside this lever we have this redstone torch is being powered, but the next one is not, because this one is transmitting weak power in the direction of this redstone lamp. Now we will be talking about blocks which emit weak power, which means daylight sensors, redstone blocks, and target blocks. Target blocks are a new addition to the game in a recent snapshots of the Nether update. So yeah, we can see that the daylight sensor is powering weakly downwards and it will power weakly in any other direction. Same is the case with the redstone block. And how a target block works is actually you shoot a projectile at this target block and it's going to emit a redstone signal. We can see that it's only powering one redstone lamp downwards, which means that it's weakly powering this block. Talking about blocks which can transmit or conduct the strong power. It can be any kind of solid block. For representation purpose, we have this smooth stone block here. It can be anything. It can be concrete, it can be wool, it could be terracotta, it could be glazed terracotta, it could be anything. Anything like a crafting table, a furnace, few redstone components like note blocks, droppers and dispensers can also conduct redstone, and also redstone lamps. Any of the workstations which have been added in the village or pillage update, which are full blocks, can also conduct redstone. Talking about blocks which cannot transmit redstone power is like any transparent block such as glass, it could be even glowstone, any kind of half slabs, stairs, pistons, hoppers, observers. I mean, they do conduct redstone, but they have a different functionality in the game, which we'll be talking about in the later part of the episode. Continuing, we have shulker boxes, any kind of liquid such as water or lava, beacons. All of these cannot conduct strong power. You can still place redstone dust on blocks like half slabs, stairs, or glass, but the only difference is that a redstone signal can travel up a slab, but it cannot down a slab. Same is the thing with glass. You can see the redstone signal goes up, but it cannot go down. Starting with the explanation of some of the redstone components around. So beginning with redstone dust. This can be obtained by mining redstone ore in survival, or you can just obtain through the creative inventory. We can see that when it's being powered, it's strongly powered, so it's going to power across this block and it is going to light the redstone lamp. Next we have the redstone block. We can see that redstone blocks are only weak powered, so this means we can only power this redstone lamp and we can only power this piston. And how you make it is you take 9 redstone dust, you place it on a crafting table, like this, and you obtain a block of redstone. Simple. Next up is a redstone torch. How this thing works is that it has a slightly different functionality than redstone dust, is that when you actually turn this on, your redstone lamp is going to turn off. It's like an inverter of a redstone dust. So you can run a redstone line, you can run a repeater, or anything you can run into this block that's going to strongly power this block, so it's always going to turn off this redstone lamp. How you make it is by having redstone and a stick. You place it on a crafting table, redstone on top, stick on the bottom, and you get a redstone torch. So our next redstone component is way over there in the distance. So we can see that there is an iron frame which tells us to go in this direction. Here we have a redstone repeater. We can already see that it has the functionality of being able to repeat the redstone signal. So if we have any kind of redstone signal which is literally from 1 to 15 anywhere, we just take a redstone repeater and we just increase the redstone strength all the way to 15, and then we can just run an even longer redstone signal. So this one is currently running for 15 blocks. We place a repeater and it's going for 15 more blocks. How you create this is by having 2 redstone torches, a piece of redstone dust, and 3 stone underneath it. So this is how you make it. Oops, you're going to a crafting table. Yeah, you need to make the redstone torches before you can make the redstone repeater. And you also need to smelt up the cobblestone. If you have any cobblestone instead of stone, you need to definitely smelt it up. So this is our repeater. Redstone repeaters have 4 different functions. Like here, we have seen that it can repeat a redstone signal. It can also delay a redstone signal. So what we see is, if you right click on repeater, we can see that we have this redstone torch which moves back and then front. What this does is actually sets the delay time for the redstone pulse or the redstone signal, which is going to travel across the repeater into this piston. We can delay this signal by 1 redstone tick, 2 redstone ticks, 3 redstone ticks, or 4 redstone ticks. 1 redstone tick is equal to 1/10 of a second. So if we actually flick this lever with the repeater on 1 tick delay, we can see that this piston turns on after 1 tick after we press this lever. Turning it off, we actually now right click it, so we have a 2 tick delay on this. Press the lever again. Now 2 ticks later, we can see that this piston extends. We can definitely see the delay when we turn it to 3 ticks, and then 4 ticks is the maximum delay. The third functionality of a repeater, yes, a repeater has 4 different functionalities, so that's a very good thing. What it does is that it can prevent redstone signals from traveling in the other direction. Like we can see, when we are powering at the back of the repeater, we can see that the repeater turns on, but when we try to power the front, nothing happens. Also, the fourth functionality is also right here. What we can do is we can actually run a repeater into the side of a repeater, and we can actually lock the redstone signal into its current state. So currently this redstone repeater is off and it has been locked because we have a repeater running into this repeater from the side. So if we flick the lever, nothing happens. Now if we turn this off, now we can change this, the state of the repeater. If we turn this on and now we run a repeater into it, it again gets locked. We can see that this is kind of a bedrock colored slider, which represents that this is a locked repeater and we cannot do anything with it. Next we have the redstone comparator, and I would actually like to tell you that please listen this one very carefully, because this is one of the most complicated redstone contraptions, or not a redstone contraption, the most complicated redstone components. How do you make one is we need to craft 3 redstone torches this time. So 1, 2, 3, you place a piece of nether quartz in the middle. So that means you need to actually go into the nether and then get some nether quartz before you actually make one in survival. You place these on a crafting table, one on the top, one on the left, one on the right. 3 redstone torches, nether quartz in the center, and then stone on all the 3 bottom blocks. So 1, 2, 3. And here you have it, a repeater. One thing that a comparator does is that it can take a redstone signal, a redstone output from containers. So like we have a a comparator running from the back of this chest. So if we place an item into this chest right here, we can see that the comparator turns on. These two redstone torches we see, they show that the comparator is turned on and now it's going to give an output. It actually depends how many items are inside of the chest. That will tell what kind of signal strength it can give out. Comparators also work across blocks. When there's a container block and we have a solid block behind it, doesn't matter, we can still place a comparator behind it. We can throw an item inside of this chest and we can see that our comparator has turned on. Hey guys, this is Plutonium here and welcome to a brand new Minecraft video on the channel Plutonium Plays. The next functionality is a bit of a very complicated functionality. So when you are listening this, please be very careful while listening to this one. So what we have here is a comparator and we have a set of different levers which can alter the redstone input into this comparator. What we see is we have a primary input at the back of the comparator and we have a secondary input at the side of the comparator. It can be any one of these sides. It can be even the right side, it can be the left side. So what this thing does is that a comparator has two different modes. Here we have it in comparison mode and subtraction mode. When we see that this redstone torch is turned on, which means that this comparator is in subtract mode. So we are currently placing in comparison mode. How this thing works is in comparison mode, when we press this lever at any one of these inputs, let's say we have an input of signal strength 11 running to the comparator. What this does is that the comparator is going to emit a redstone signal at the front when the secondary input is smaller than the primary input in signal strength. So we have a redstone signal of 11 running to this comparator. We have a signal strength of 11 running out of here. So we can see the output goes 11 blocks, which is right here. Next we have, if we say we added a secondary input which is higher than the primary input, say we have put 12, we can see that now since this redstone has higher power than this, so the output is off. Next we have this comparator in subtract mode. How this thing works is that when we have the primary input set to any value, say we call it A, and we have the secondary input which is going to be our B. So what this thing does is when we have a primary input turn on and a secondary input turn on at a particular value, here we have the secondary input as 10 and our primary input as 13. What this thing does is the output is actually the difference between the primary input and the secondary input. What we see here is that when we actually give a primary input of 13 and a secondary input of 10, we get an output of 13 minus 10, which is equal to 3. Here we can see an output of 3. Now if we actually turn off this lever here and we actually set it to a value higher than the value that we have set here, this is 13, that's okay, that's the same. If we say 14, right, if we have an input which is larger than the primary input as the secondary input, then obviously we have to subtract 14 from 13, which gives -1, which is not actually a redstone signal strength. So the output is actually off. So we can see this comparator is actually turned off. Next up is what I'll probably call one of the most important additions to the game in terms of redstone. That's the observer. We can see that an observer is a block with a cute little face looking in this direction. Actually, you can place it in any other direction. We have an arrow at the top which shows that the redstone signal is actually going to travel backwards, and here we have a redstone dot which shows that the redstone signal is going to come out from this side of the block. What it does is it actually detects block updates. So we have this face to represent that it's actually going to look at the block in front of it and it's going to detect a block update, and then it's going to give a redstone output for a really brief amount of time, which is about one redstone tick. Now, what could be a block update? We can say that if we place a block in front of an observer, we can see that the observer detects that as a block update. It's going to give out a redstone signal, and we just saw that this piston extended and then very quickly retracted back almost instantly. So it's a very short pulse. If you remove a block, if you remove a block, that's also a redstone update. If there is a string placed in front of the observer and you are actually standing where that string is, so that's also considered as a block update. So this is actually checked by the observer and it pushes the piston. If we walk out, that's also another block update. If we switch on a button, that's also going to do. If we flick a lever, that's also going to do. We stand on a pressure plate, that's also another block update. If we place an observer in front of an observer, both facing it together, what we see is an observer clock. It's a very small redstone contraption. It's actually a redstone clock with two observers facing each other. So what is actually happening here is this this observer is detecting that I've placed an observer in front of this observer. So it's going to detect that and then it's going to give out a redstone output. Now when it's detecting it, that's also another block update. So it's going to detect, so this observer is going to detect it, which means this is again going to detect it, and then it's going to push the piston up and down. So this goes on continuously, creating a redstone clock. It can also detect when hoppers are getting locked. So what we see is actually we are flicking a lever, so it's actually going to power this hopper, and when this hopper gets powered, it actually gets locked. We'll be talking about in the later part of the video. What we can see is when you actually unlock or lock a hopper, that's also a redstone update or a block update. When you turn on or off a dispenser, that's also a block update. You open or close doors, that's also an update. You extend or retract a piston, that's also an update. And if you turn on a redstone torch, that's also an update. Next, we have the pistons and the sticky pistons, the pistons with a slimy appearance on the front. What pistons do? They push blocks. That's really the functionality of a piston, right? Even in real life, they can push blocks. A piston in Minecraft can push up to 12 blocks. We have a line of 12 blocks in front of this piston, which it can push. And if we place a 13th block, which we are just showing here, if we place a 13th block and now we try to push this piston, it's not going to do anything. A sticky piston, we now actually see the face of the sticky piston, is that a sticky piston can push as well as pull blocks. So when it extends, it's going to push the block, and when it's retracting, it can get back that block. Now there's a very interesting functionality of a sticky piston in Java edition is that when you actually have an observer or actually anything that gives a one tick pulse, a very short pulse to this piston, it's actually going to get rid of that block when it's extending, and on the next time when you're actually giving it that pulse, it's going to retract that block. So what we are doing here is when we're actually giving it a one tick pulse through this observer, it's going to get rid of its block. It does that so quickly that the block is actually being missed by this piston. This is actually a very cool feature which can be used in making different kinds of contraptions, like we have this T flip-flop over here. What we have is behind this piston we have a setup called a monostable circuit, which gives a really short pulse, which is actually a one tick pulse in this case. If we press this button, we have that piston pushing that block over this redstone torch, which is going to power this redstone. A T flip-flop is actually something which gives a button the functionality of a lever. So when this happens is when we press this button again and that block is retracted, which means now that redstone is not going to get powered. Now there is some limitations when pistons are actually pushing blocks. So there's a long list of blocks that pistons cannot push. These are obsidian, chests, furnaces, blast furnaces, anvils, beacons, bedrock, dispensers, hoppers, droppers, and jukeboxes. This is a jukebox. And we can see that we have placed a redstone torch beside all of these pistons. Even if these pistons are being powered, they are not going to push the blocks in front. So these are immovable blocks. Next up, we have dispensers and droppers. What dispensers and droppers do? They have two completely different functionalities. Dispensers can dispense things. They can dispense liquids in a block in front of them, or you can just do this. You can dispense lava. When you press the button again, if you have a bucket, an empty bucket inside of this, then you can attract the water as well. When you actually press this button, the water gets dispensed and we have an empty bucket here. Now what we can do is we can press this button again and the water will be withdrawn, and now we have a water bucket inside. Similarly, we can do this with a lava bucket. A dispenser can dispense projectiles like this arrow. Ow, that really hurt. So we have this here. It can dispense TNT, and that TNT will be immediately primed. So what I've done is actually I've placed some water here to actually dampen the effect of TNT. So when we actually place this, we have TNT and it is going to blow up. It's actually not going to cause any damage because it's underwater. Dispensers can dispense pumpkin heads on top of iron golem bodies, like here. There you go. I got an advancement here. And they can also dispense. Oh, what I was saying is that they can also dispense pumpkins on snow golems, which we just saw here. And we got 11 snowballs. What a dropper can do is just, it drops a block. Just anything. That's it. We're almost at the end, guys. We are nearly at the end of some of our most important things here. We have hoppers. Hoppers are actually blocks which can transfer items from one container to the other. So here we have a situation where we have a chest. Underneath it we have a hopper and we have a dropper with a mechanism to even dispense that block in back to us. So if you place that block of iron over there, it actually gets transported from this chest to this dropper immediately from using this hopper, and then it gets dispensed to me. That's alright. But when you actually place a redstone block or anything that is powering this hopper, when you power a hopper, it gets locked and it cannot transport items, which you can see here. We have a block of redstone inside this chest which is not getting moved from this into the hopper. So when you actually place when you actually power a hopper, it gets locked. Finally, we come to these, the chest minecarts and the hopper minecarts. What these things do is they have the same functionality as that of a chest or a hopper. But what these things can do is, since these are in minecarts, so we can actually transport them on rails. Currently we don't have them on any rails. And what you can do is you can actually open a minecart in a chest, and now this item can be transported on the rails. A hopper minecart does the similar function as a hopper, but it can also transmit items much faster than a normal hopper. Also, what we can see here is that when you actually place a minecart hopper underneath a block, a hopper minecart, when on a rail, can easily collect items from one block above the hopper minecart itself, which means even if you have a block, you can just drop an item over here and you just saw it disappeared and it went into this chest. Simple as it can be. So guys, unfortunately that's all for today's video. I hope you liked this video, and if you did, please like, subscribe to Plutonium Plays channel, and thanks for watching.